Good day, grade 9 mathematicians. I'm going to deal with the topic solving equations with exponents. So these equations have got exponents. So whenever I'm solving equations that have got exponents, I use the following steps. One, change the base to a common base. So we have to change bases of the numbers to a common base. Then the second thing, we equate exponents parts. We equate exponents parts. In other words, we've got the exponents that we have there. So we'll just make an equation out of the exponents only. Then number three, solve the equated exponents. So the exponents that we have in number two are the ones that we are going to solve to find the variable x. Now, I've got few examples here. Solve the following equations. Now, before I start working out these problems, please forgive me for poor shapes of letters and numbers, right? Right. So I'm just going to deal with question number one. That's question one. These are now the answers. So we are looking at question one, which says 3 to exponent x. This is the number one that I'm talking about. Is 3 to exponent x is equals to 27. Now, so we are going to deal with that one. Then we move on. Right, let me just type question one here. So that's question one. Right. So what we are just going to do when solving this problem, remember the three steps that I talked about. So I'm going to make use of those steps that I mentioned above. So the first thing is just a matter of changing our basis. Let me then copy the problem that we are solving here. That's 3 exponent x is equals to 27. Now, in this case, you can see here that on the left-hand side, we have got base 3. On the right-hand side, we have got base 27. So these are not common bases. So we must have a common what? Base. So checking on to the left-hand side, we have got 3, which is a prime factor. So I'm going to express 27 as a product of its prime factor. Then I write it in index form, right? Which means if I am to find the factors of 27, 27 can be broken down into, we have here, that's 27. So I'm going to use factorization method. So we have 3 into 27 will come up with 9, right? Then the next prime factor for 9 is 3, which means 3 into 9, it gives us 3. Sorry for my poor handwriting. Then the next prime factor is again what? 3, which means 3 into 3, it gives us 1. So you can see here that we are multiplying 3 times. So it means I can rewrite my exponential equation as 3 to exponent x is equals to, then I'm now using base 3 now, right, which is 3 to exponent 3. So in this case, we have changed our exponential equation into an equation that has got common basis, right? Then thereafter, I am now going to equate the exponents only. So which ones are the exponents? The exponent on the left-hand side, it's x, which is equals to the exponent on the right-hand side. The exponent on the right-hand side is what? 3. So here, our left-hand side is simplified, the right-hand side is simplified, then everything is done. Then this is our final what? Answer. Then I move on to number 2. Right, on number 2, if you can just see there, we have got um, 5 to exponent x is equals to 0 0.008, right? That's 5 to exponent x is equals to, that's 0 0.008. Sorry for uh, my shape of numbers. Right, so what I'm going to do, like I said earlier on, the first step, I must make sure that the bases are exactly the same. Now, if you note, this is a decimal number, so 0.08 is the same as 1 over, I'm changing it into fraction, is the same as 1 over 125, right? Then if I change 1 over 125, it is the same as, that's 1 over 5 to exponent 3, right? That's exactly the same. So I'm going to take the denominator into the exponent, which means it become what? The exponent, sorry, I'm taking the denominator into the numerator, not into the exponent. I'm taking the denominator into the numerator. So in the numerator, we've got 1. So we multiply by the incoming number, which is 5 to exponent. Now, since I'm moving a number from denominator to numerator, the exponent becomes negative, right? So which means when I simplify 1 times 5 to exponent negative 5, will come up with 5 to exponent negative 3. So what it simply means here is we are saying 0.008 is the same as 5 to exponent negative what? Negative 3, right? If you use a calculator, enter 0.008, then you change it by using SD into a fraction, you'll get 1 over 25, right? Now, then you convert 1 over 125 into exponential what? Form, or in index form. Then it becomes 5 to exponent negative 3. That's the same, right? So it now means here that my 5 to exponent x is equals to, then it's 5 to exponent negative 3. Now, we now have common base on left-hand side and right-hand side. Our common base is what? 5. So we now equate the exponent parts. So on the left-hand side, we've got exponent x, which is equals to exponent negative 3 on the right-hand side. Now, this one is simplified. there's nothing to simplify on the left hand side, and there's nothing to simplify on the right hand side, which means this is our answer. Right, I'm not saying all our answers must be having 3. It depends with the exponential equation that you are dealing with, right? Then number 3, question number 3 says 16 to exponent x plus 3 is equals to 128. So let us look at that one. The exponents has got a binomial, right? It has got a binomial. So let us quickly look at it and deal with the problem. So it's 16 exponent x plus 3. Which is equals to 128. Now, if you check here, on the left hand side, we have base 16. On the right hand side, we have base 128. So you can see there that we cannot express 128 in terms of powers of 16. So what we can then do there is to express 16 as a product of its factor in index form. Then we also express 128 as a product of its prime factors in index form, right? You use factorization. Remember the factorization method that I used um, on the first one, right? Where we found the factors of 27. So you are going to use that method to find the factors of 16. Now, if you use that method there, you will find out that expressing 16 as a product of its prime factors in index form, we are going to come up with 2 to exponent 4, right? That's 2 to exponent 4 is 16. Then 128 as a product of its prime factors in index form is equals to 2 to exponent 7. Right, so I'm going to convert the bases in terms of powers of 2. 16, remember 16 is 2 to exponent 4. This is my 16. So this 16 is raised to exponent x plus 3. Then 128 in terms of powers of 2 is 2 to exponent 7. Right, then I'm going to simplify my left hand side. We can see there that we have got 2 exponents raising the same base. We have got exponent 4 and exponent x plus 3. So when we have such a situation, remember 2 or more exponents raising the same base will multiply each other. That's the laws of exponents. So the 4 is going to multiply the exponent x plus 3. And this is equals to 2 to exponent 7. Now, so we now have a simplified exponent, which then means that uh, according to our rule number 3, we said if we've got the same basis, then number 2 says the um, equate the exponents, which means it's now 4. The exponent on the left hand side, it's 4 into x, or 4 multiplied by x plus 3. The exponent on the right hand side is 7. So from there, I will then remove brackets, right? Which means 4x, it will be 4x then 4 times 3, which is 12, is equals to 7. Then from there, I transpose what? I then transpose 12. When I transpose 12, I'm going to remain with 4x on the left-hand side. Then it becomes 7 minus 12. Remember, when we are transposing a full term, the additive inverse that we will use there is negative 12, because we are transposing positive 12. So it becomes negative. Then which means now that 4x on the left hand side is now equals to 7 minus 12. It gives us minus 5. Right, allow me to make use of this space on the right hand side, right? Now, so it now then means that 4x, which is equals to negative 5, we have to transpose what? 4. 4 is multiplying x. So when we transpose that 4, it will then become what? Division. So we are using the multiplicative inverse of what? 4. So it's like we are saying we divide both sides by 4. So when we divide both sides by 4, we are going to have x on the left hand side, which then is equals to, then we have minus 5 over 4. So it means our value of x is equals to negative 5 over 4. So that's our final value. So that's how we just work out problems that are having exponents. So remember, it's just a recap. We just make sure that the bases are common. Then 2, equate the exponents parts only. Then solve the equated exponents. That's how we deal with an equation that has got exponents.